How do you find the domain of a composite function that combines a rational function and a linear function, given that our f of x is equal 1 all over x and our g of x is equal to x minus 1? Find the domain of f of g. Solution. First, we find the composite, which will give us f of g of x, meaning anywhere we have x in f, we'll replace it with g of x, and this will give us 1 all over x. Instead of writing x, we are going to have g of x, which is 2x minus 1. This is the composition. Now, how do we get the domain? We check for restrictions. That is the first step. And when you have a rational function, one of the restrictions is that you cannot divide by 0, meaning that 2x, which is the denominator, 2x minus 1, cannot equal 0. Now, how do we get the value of x? If we solve for x, let's say 2x minus 1 cannot equal 0. Now, we solve for x, 2x cannot equal minus 1. Minus 1 crosses over to this side. It becomes plus 1. Alright, so that our x cannot equal 1 all over 2 if we divide both sides by 2. So, the value of x here will give us x cannot equal 1 all over 2. Sorry, x cannot equal 1 all over 2. How do we now write out the domain? Starting with set notation. X is a set of all real numbers, but x cannot equal 1 all over 2. Writing in interval notation, we are going to have that x is a set of all real numbers. You remember real numbers begin with negative infinity to positive infinity. So from negative infinity to 1 all over 2 union 1 over 2 to positive infinity. And that is the final answer. For those who asked what is the difference between writing this set notation, which is x for x not equal 1 over 2, it is absolutely the same. If you write it like this, it's the same thing as writing x set of all real numbers where x is not equal 1 all over 2, right? So it is the same.